So one of the things we want to be able to do with rational expressions is we want to be able to simplify them. And at this point, you may be thinking, well, rational expressions kind of remind me of fractions. Yeah, some of the same rules that we apply in fractions, we also apply to rational expressions. So think back when you had something like 15 over 20 as a fraction. That's a value, a numeric number. But they would want you to simplify it, right? So however you simplified it, you came up with, well, that's equivalent to 3/4. Okay? And we're going to talk about how we simplify that. But it has to do with factors. So if you have 3 times 5 for 15, and you have 4 times 5 for 20, you can cancel those factors. And that's how we get the 3/4. Remember, factors are things that are multiplied. So now we're going to look at 2 examples. This first example here, what is the factor in the numerator? You just have x plus 2 as the factor. Now I'm going to erase what I just drew, that circle. It might help you to put parentheses around it, and that will remind you that that is all one factor. It's times 1, but you can't take part of the addition away. they're together. And it's the same in the denominator. That x plus 3 is together because it's addition, it's not multiplication. If you could factor x plus 2, you would, but it doesn't factor. And the same with the x plus 3, but it doesn't factor. So that problem is done. You can't simplify it anymore. A lot of times students want to cancel those x's, but you can't do that because then you're splitting up that addition and you don't have a factor of x. Now look at the next example, and this might make more sense, might bring it together for you. Now you have 2 times x, and in the denominator you have 3 times x. So the factors in the numerator are 2 and x. The factors in the denominator are 3 and x. So do you have a factor that's the same in the numerator and the denominator? Yes. And so that one you can simplify, like that. That one you can simplify to 2/3. Okay, so we wanted to point out the difference there. Okay, so it takes practice, but that's what we're going to do. We're going to have some practice. And this comes down to the equivalent fractions property. It says that if you have a times c over b times c, that just equals a over b. Because those c's just make a 1. C over c is 1, okay? And provided that c is not 0. Okay, so with this first example we have, those are numeric factors. And so you see you have 2 times 3 times 7 in the numerator, in the denominator 3 times 5 times 7. So you can cancel the 3's. Sometimes I like to cancel in a different color. And you can cancel the 7's. And so your answer is going to be 2 over 5. All right, let's go to the next problem. So you look at the factors in the numerator. You have 3 times x minus 9. In the denominator, you have 5 times x minus 9. So if there's a factor that's the same in the numerator as the denominator, you get to cross those out. So what's the answer? 3x over 5 in this case. All right, the last one. In the numerator, you have a factor of x plus 5, and in the denominator, you have a factor of x. So do you have any factors the same? No. So this one's done because you can't cancel anything. I know it's tempting, but you can't cancel anything there because you do not have a factor of x in the numerator. Now, some of you might be saying, I know the what if game, sometimes students are like, well, what if I had this? Could I cancel those x's? Yeah, those you could cancel. And then you just have x plus 5. And the fact that the denominator is 1, you don't have to write that. But you don't even need the parentheses, but it makes it a little clearer. Okay, so that's what we're doing there.